Welcome to Ask and Learn.
We want to sketch the graph by hand using asymptotes and intercepts of f of x is equal to x plus 4 times x minus 3 squared over x to the fourth times x minus 1. Then we want to use our sketch as a guide to producing graphs that will display the major features of the curve, and we're going to use that graph to estimate the maximum and minimum values. So let's go ahead and first just figure out where all of our horizontal, or where all of our vertical and horizontal asymptotes are going to be. So let me just go ahead and draw a little graph here. So 1, 2, 3, 4. 1, 2, 3, 4. All right. Now, remember, we get vertical asymptotes when our denominator is equal to 0. So that tells us x is equal to 0 or x is equal to 1. And something else you're going to want to know is the multiplicity of these. So multiplicity. So this here is 4 and x is just going to be 1. Now to find our, actually, so let's plot those first. So at x is equal to 0 and x is equal to 1. Now let's go ahead and find our horizontal. And so in this case, remember what we do is we look for our largest power in the numerator and the denominator, which in this case is going to be x to the fifth. And I'm going to multiply the top and bottom by x to the fifth. And doing that will give us, so x plus 4, x minus 3 squared over 1 over x to the fifth times x to the fourth, x minus 1 over x to the fifth. Now the x to the fourth and x to the fifth just becomes 1 over x, and I can distribute the rest of that into the denominator to just get 1 over 1 minus x. And in the numerator, I can distribute 2 of them inside of x minus 3, and doing that will give x minus 3 over 1 over 3 over x squared. And the other 3 I can distribute to x plus 4. And doing that would give 1 over x squared plus 4 over x. And let me go ahead and write that a little bit clearer. So it would be 4 over x cubed plus 1 over x squared. All right, so now as x approaches infinity, well, all the 1 over x terms are going to go to 0. So I can rewrite that as 0 plus 0. 1 minus 0 squared over 1 minus 0, which goes to 0. So that tells us our horizontal asymptote is at y is equal to 0. So let's go ahead and plot that as well. Y is equal to 0. All right, and then lastly, for our intercepts, we go ahead and set the numerator equal to 0, or at least for our x-intercepts. And doing that will tell us that x should be negative 4 or x is equal to 3. And again, we should just go ahead and say what the multiplicities of these are. Well, for 4 or negative 4, it's 1, and for 3, it's 2. All right. Now, what we want to do is to decide if we're going to start above or below, or on one side of our vertical asymptote, either going to negative or positive infinity. So I'm just going to go ahead and look at x is equal to 0. So let's look at the limit as x approaches 0 from the right of x plus 4, x minus 3 squared over x to the fourth, x minus 1. Now, 0, or x plus 4, if I approach this from the right, well, x is going to be a positive number. If I add that to something positive, that'll be positive. Now, if I approach x minus 3 from the right, it's going to be negative 3, but if I square that, it becomes positive. If I approach x to the 4th from the right, well, I'd be raising a positive number to 4, so that's going to be positive. And then x minus 1, that's going to be negative. So I have 3 positives, 1 negative, so this tells me this should go to negative infinity. So to the right of x is equal to 0, I'm going to go to negative infinity. And now this is all I really need to know. And let me just go ahead and also plot my intercepts really quickly. So 3 and negative 4. All right, so between x is equal to 0 and 1, I know I have no intercepts, so it's going to curve up like this, and then have to curve back down at some point. And then, since x is equal to 1, has a multiplicity of 1 for its horizontal or vertical asymptote, that means it's going to have to start from the opposite side, like this. And then it's going to approach our x-intercept, which is 3. And since x is equal to 2 as a multiplicity of 2, we know it's going to bounce off. And so it's going to have to increase for a little bit, and then it has to start decreasing again. So we will approach our our horizontal asymptote at y is equal to 0. So that takes care of everything on the right side of our graph. Now on the left side, so x is equal to 0 has a multiplicity of 4. So since it's even, they should start on the same side, or they should be on the same side of our vertical asymptote. So this side will also go to negative infinity, and then it's just going to go up until we hit our x-intercept. And then I'm going to pass through the x-intercept. And then at some point it's going to have to peak so I can start decreasing and approach my y-axis again. So looking at this, the thing they tell us we want to do is to determine what these maximum and minimums are going to be. The little green, maybe I'll put little x's instead of dots, are going to be. So we know we're going to have a local max slightly to the left of our intercept at negative 4. Somewhere between 0 and 1, we're going to have a maximum, local maximum. At x is equal to 3, we know we're going to have a local min. And somewhere after x is equal to 3, we will have a local max. So we can go ahead and use this now to actually produce a graph. And so I went ahead and did that already. And this is the nice little graph I got. So all I did to get this was I kept zooming out until I actually saw this part here between 0 and 1. And then I just kept on going on the x and y direction until I actually found values where it looked like it starts to decrease again. So I went ahead and estimated these points, and we have that at 0.821 minus 28146, we have a local max. To the left of our intercept of negative 4, we have negative 5.57 and 0.018. We know for sure that we have a minimum at 0.3, so we didn't really need to estimate that one. And then to the right of that, we have a maximum at 5.249 and 0.015.